Get started.
So while we're waiting,
Start now. Go ahead. Yeah, sorry.
Hi everybody. We're just gonna wait a couple minutes to get started. While we're waiting, since today we're gonna be talking about the color spectrum, if you just want to drop in the comments where you're from and what your favorite color is, and we'll wait about 2 minutes for other people to join. Personally, my favorite color is orange. I like how bright it is. I don't know. Fun. What's your favorite color?
Either blue or purple.
Blue or purple. Alright. Hanging out, waiting just another minute to get started. I also really like blue. Blue is a good second favorite color of mine. Do we have any comments popping up? Not yet. Might take a second.
Sam, what's your favorite color?
I think blue.
Blue's a good
Yeah.
color.
Yeah. It's hard to pick.
Alright, let's see. We'll wait just one more minute and then we can start. Alright, we'll go ahead and get started. So my name is Marie Cordes and I'm an outdoor program manager in the North region for Girl Scouts of Western Ohio. And today we're going to be working on the Space Science Researcher Badge for cadets. So we're going to cover steps 1 and 2 and then we'll give you a couple different suggestions for how to complete steps 3 through 5. And today with me I have Sam and Heidi from the GSWO Astronomy Club. So they're going to be telling you guys about some of the activities and also teaching a little bit about the telescope. So to get started, I'm going to switch out here and we'll start with some activities.
Hey, I'm Sam. So we're going to start out with the Make Prism Pictures activity. It's getting a little windy. So for that, what we're going to use, today we're going to use a glass of water and some CD. You can also do this if you have a prism or some diffraction gratings or things like that. So it works out nicer if it's a bit sunnier out, but it's a little windy and cloudy today, so we're going to do it with a flashlight. And so we've got a regular flashlight here, and it looks like just white light coming out. And then if you want to come a little closer. So if we kind of change, if we go in here with the flashlight through the water, you can see where it starts to diffract it, and you kind of get a rainbow there. And then if you take, so if you're in your notebook, try and take some colored pencil or something, you can kind of color it in and see your rainbow. You can kind of see where my rainbow is right there, and if I move the glass.
It looks like they're having a hard time hearing us, so we gotta talk up a little bit louder.
Sorry. So if you look right here, you can kind of see the rainbow. As the white light comes through, it diffracts it, and then you get all the rainbow, so it kind of breaks apart, and you get all the different colors here. So it's a little bit with the glass of water. You can try this at home too and experiment with different sizes of water, maybe some different like shapes and see what happens there, different flashlights. Or if it's sunnier out, definitely try it with the sun. And then I've got some CDs over here, which you can see it a little nicer with the CD. You kind of come in there. And what's happening here is you've got the light from the flashlight coming in, and then all of your lines on your CD are then, where it's reflecting the light, and then you're getting the rainbow down there. So you can kind of see that. Do you think you want to add to that, Heidi, at all?
If you look at the top of the CD, there you go, I can come a little closer.
Yeah.
If you look at the top of the CD, you can actually see where the sunlight is causing the rainbows to form on the very top of it. Because even though it's cloudy out today, you don't really have sun shining nicely, but if you just put a little bit of light on it, it can cause little rainbows. But when light goes through any type of prism, it can cause the light to break apart into all the different colors of the spectrum, all the ones that we know, red, orange, green, blue, violet, indigo. But we also have the different colors that we can't see. So infrared, ultraviolet, and even microwaves and other things like that we use for other things. But you can see that if you do the different activities that are in the packet that we can't unfortunately do without the sun today. But if you look at the packet for this activity, you can do those on your own. That's all I have to add to this one.
So that's how you can kind of see how to make rainbows with some everyday objects. You can also, if you're at home and it's nice and sunny out, you can grab a hose and kind of face your back towards the sun, and then with the hose you can see a rainbow there. So that's another way you can try and create a rainbow. And then step 2, one of the options there are to make sun prints. So for that, what you need is some sunscreen, some blue construction paper or green. Green works okay too, but blue kind of works the best. But darker colors of construction paper, and then some saran wrap. And what you want to think about here is all the light that's kind of around. You're not seeing, like how you get sunburnt, you're not really seeing that light hit you and kind of affect you. So to do this, we're going to start out and get some saran wrap. Maybe. The trickiest part is getting that out. Okay, so we've got our saran wrap, and I'm going to get that out. Just enough to cover up our paper. And then if you fold over the edges, you can kind of tape them. I would probably tape them to help them stay. So the saran wrap is really to protect your construction paper, so then you can put the sunscreen on top. So again, for this one, you're going to want blue or green construction paper, some darker color. Okay, so we've got our saran wrap on top, covering it nicely. And then we're going to take some sunscreen. You want to use at least 30 or 50 SPF. You can do lighter ones too, you're not going to get as noticeable of results. You take your hand, and squirt some sunscreen out, wipe it around, and then you can kind of make some handprints. I'm going to make a nice little smiley face. So you see here I've got the sunscreen on the paper, and then you want to leave this outside for about 3 to 4 hours and then come back and you can take your saran wrap and see what it looks like. It's not too sunny out today for another day to actually put it outside, but over here I have what it would look like. So here I've got, that's okay. Right here I've got one I did a few days ago, and you can see my handprint there. And then, so here I was using 30 SPF, so you can kind of see how the sun faded on my paper and kind of what changed it. And this darker, but here I had, I think, a rock sitting there, so you could also play with some shapes, maybe some like flowers, something like that, and put those down and see how those look. And this was the same, so you can see how much the green paper faded. And then keep asking that blue one under there. Yep. The one that has that one. And then you can see 2 different handprints here. So this one I think I did 30 SPF, and that one was like 15. So you can kind of play with different SPFs and some different shapes and kind of see what happens and see what that looks like.
Yeah, so you actually get to see 2 different things when you're doing this. So with this one, you're seeing how the sun actually bleaches the paper. So you can see you can get a little closer. The same thing that kind of happens with your with your skin. The sun tans it and makes it a lighter color, in the paper's case. In your case, you've got some special cells in your skin that make it a darker color. But the sunscreen helps protect it and makes it, or keeps it the same color that it used to be, which in this case is the same color as this, or close to it. But if you look at the saran wrap when you take it off, this sunscreen will have dried, and you might be able to look through it and see some rainbows, because with your fingerprints, they trapped the sunscreen and might make some diffraction gradients, which help you see rainbows. They're pretty cool. What's the next step? Telescope. All right. This right here is our telescope that we use for our astronomy meetings when it's clear outside. Unfortunately, here in Ohio, we don't get that quite as much as we hope. But this is a sorry, forgetting words. This is our telescope. It is a reflecting telescope. Excuse me. The difference between a reflecting telescope and a refracting telescope. Sorry, we're standing far enough apart. Take that off so you guys can hear me a little bit better. The difference between a refracting telescope and a reflecting telescope is what's inside of it. So, inside of a refracting telescope, there are lenses. So lenses like what's in your glasses or in windows even. Except they're constructed a little bit differently. They're special lenses, so they magnify the light. In refracting telescopes, there are mirrors. So if you want to take a look down the tube, you can see that there's mirrors inside of there. And I have a diagram over here we're going to take a look at. Put this back on. I can walk you come close. Alright, so this is what the inside of the telescope looks like. This is a bad drawing of an eye. So this is what the telescope looks like. Right here we have the back of the telescope where the primary mirror is. And this is what the size of this mirror is how we tell, or how we call the telescope, like what we say it is. In this case we have a 8-inch telescope. So this one would be 8 inches. 8 inches across. So the light goes in this way. And these are just thin bars that hold it in place, as you saw when you looked down the telescope. But the light goes in this way and bounces off this curved mirror. And it's curved just enough that when the light goes in, it hits it and bounces it right up to this special secondary mirror, which is much, much smaller, and was that little circle that you saw in the center. And this one is curved at an angle so that it can go directly into the eyepiece and into your eye, so you can see it. And by bouncing the light around, we're able to get a much longer length of telescope and have the light more condensed down. That's okay. You can have it much more condensed down and collect a lot more light, so it's much brighter for us. So the same point of light that we see in the sky can be focused into a really pretty star or nebula that we can see, instead of just a point of light. The same type of telescope, or same power of telescope in a refracting telescope that works by magnifying the light through the lenses would have to be much, much longer, because it, instead of bouncing it around, it has to go through pieces at two ends and has to go down this whole bounced length in one long length. So we're able to get much more clarity in a much shorter space with our telescope. You can look at a bunch of different telescopes on sites like Sky and Telescope or astronomy.com if you're interested in this kind of thing. Or come to our astronomy meetings and ask questions.
Yeah.
So we showed you guys how to do step 1 and step 2 of this badge. For step 3, you can work on being an astrophotographer. So you can go outside and try and take pictures of the moon or just the sky at night, or even take pictures of a sunrise and sunset. And if you try that tonight, go ahead and post your pictures in this video so we can see them in the comments. But yeah, so try and take some pictures outside. Astrophotography can be really hard, but give it a go and kind of see what you can get and see what you can do. Step 4 is part of observing the night sky. So again, go outside, look at the stars. You could even take a notebook and kind of start your own like astronomy journal and kind of track the stars, even the moon phases throughout the night, and kind of track those changes every night and each day. And then step 5 is light pollution. Heidi, if you want to add some about that, about lights.
So if you, many people in our area live in cities, and a lot of other ones don't. I guess that was very ambiguous. But if you go outside at night, compare your sky to what it'd be like if you were staying at camp right now, or when you've stayed at camp. Because the skies here are much, much clearer than if they were in the city. So take a look at your night sky. Can you see clouds at night? If you had no light pollution in your city, you wouldn't be able to see clouds. In fact, before electric lights were invented, native peoples could tell if there was a storm coming and if there were clouds by the lack of stars, not actually being able to see clouds at night. So it's a new phenomena, actually being able to see clouds. So take a look at what you can see, and take a look at the type of lights you have around your city, around your house. Do they point upward, or do they have different caps on them, where all the light is pointed down? And just take a look at what kind of lights are around and how that affects what you can see, how many stars you can see at night, and different places that you visit.
So Heidi mentioned before that we have an astronomy club. So the astronomy club is for cadets, seniors, and ambassadors, and we meet every third Saturday of the month. Right now we're doing all our meeting through Zoom calls, but you're always welcome to join. Typically we try and do, in normal circumstances, we typically do every other meeting in person here at camp or somewhere else, like maybe at a planetarium, so we can observe a little better. But you're always welcome to come. They're typically around 6 p.m. We have a Facebook and Instagram page, and those are GSWO Astronomy. And then if you'd ever like to email us or ask any questions, the email is gswoastronomy@gmail.com. Even if you're not interested, I'd love if you check out the Facebook and Instagram, give us a follow, check it out. The group, you can always post any cool new astronomy things you see. The meetings, we'll meet, play some games, hang out, and then we usually have some sort of theme or subject, and then we go into kind of what's happening right now, some exciting space news and astronomy news, and just kind of chat about everything awesome that's going on.
And we're always happy to answer any astronomy questions, either at our meetings or on our social media. So even if you don't want to come to our meetings, post it on our social media and we're happy to answer them for you.
And you're always welcome to join anytime. If you can't come one month, but you want to come the next, we'd always love to have you there.
All right, you want to switch out and I'll say one more thing?
Okay, so I do have one request for you guys. We actually have someone who's an engineer that works for NASA, and she's going to be making a video for us answering any questions that we might have, about having a career with NASA, anything related to engineering, NASA, any of that kind of stuff. So if you guys could drop in the comments some of your questions that you have for her, and then stay tuned for that video to come out soon, so you can just see what she answered for your questions. So if you could just put them in the question log, that would be awesome. If you guys enjoyed this and you're not a Girl Scout yet, please go out to girlscouts.org/join, and you can learn more about becoming a member of Girl Scouts. And if you guys also enjoyed this, check out on Friday at 2 p.m. We'll be having another cadet badge. And I think that's all we have for you guys. So if you do have any questions, feel free to leave them in the comments, and we'll make sure Sam and Heidi can answer them for you. And I hope you guys join us soon.